Hey guys, Mr. Middleton here. Today we're looking at law of cosines notes. At the end of this video, you should be able to determine when to use law of cosines, and you should be able to use the law of cosines to find missing side lengths and angle measures. Okay, looking at this triangle, why is using the law of sines not possible here? In this problem, we can't use law of sines because we don't have an angle and its corresponding side. Even though we have two sides, we don't have an angle that goes with it, and we have the angle, we don't have the side that goes with it. Okay, so we can't use law of cosines because we don't have a complete ratio. Okay, or yeah, we'll call it a ratio. Okay, so we have to use a different tool to find x, and that tool is called the law of cosines. Okay, is it necessary to memorize all three of the law of cosines because you see them here? The answer is no. Okay, if you can spot some of the common pieces to each, you don't have to memorize it, you'll just kind of know it. Okay, remember that the lowercase letters represent sides and the capital letters represent angles. Okay, and the side that's by itself matches the angle in the end. Okay, the other two sides are in the side portion of the formula. Okay, so you look at this, you have a squared plus b squared plus c squared equals, or you have a squared equals b squared plus c squared minus 2bc cosine a. Again, sounds like a lot, but you'll notice that a squared cosine a together. B squared, C squared, that's all seems like a Pythagorean's theorem, and this minus 2BC, right? These two sides back here, the 2BC. All right, as you look at it more, it gets more and more familiar. Okay, so it says use the law of cosines to find the value of x above, give your answer to the nearest 10. So we're looking for finding this value x. Remember, in our formula, we'd say that's sine, or the side A. So how we would set this up is we'd say x squared equals 21 squared plus 42 squared, 42 squared minus 2, 21, 42 times cosine 39. Okay, and that's just plugging away our values in there. Okay, it does not matter what you call side B and side C. Okay, if you call side C side B, it won't matter. Okay, so now using our calculator, simplifying, I would always suggest that you kind of break this up a little bit. Do these separately and subtract. So that's what I'm going to do here. 21 squared plus, what was the other one? 42 squared should equal 2205. Okay, and then on the other side, I've got 2 times 21 times 42. 1764 cosine 39. So back to my calculator. All right, so 39 cosine times 1764. And it gives me 1,370. Oops, 1,370. So this is that. 0.885. All right. The better you can keep this into your calculator, the easier it'll be, I guess, for your numbers. Okay, and so now I have those two values. I'm going to subtract them here. So I have 2205 minus 1370.885, and that gives me 834.11. So x squared equals 834.11. I need to find out what x is, so I'm going to take the square root of that number, and I get 28.88. or 28.9 to the nearest 10th. Okay, here's a super common mistake, guys. Super common mistake in this problem. You'll see that we avoided it because we've separated them, right? But a super common mistake is that a lot of people will take these two numbers, 2,205 minus, and then subtract 1,764 from it, and then do 441 cosine 39. Okay, please don't do that. You can avoid that by approaching it the way that I told you to and taking these things separately. Okay, and then subtracting afterwards. Okay. A couple more examples on this next page. Okay, so looking at the second page here, it says use the appropriate law to find the missing side lengths and or angle measures. Find the measure L to the nearest 10th of a degree. So asking us to find the measure of angle L here. We would probably, as you guys have seen just at least through this one example, want to use law of cosine if possible, okay, because it's just a ratio, cross multiply, solve. Here we see that that's not possible because we don't have any corresponding angles and sides. So we'll have to use law of cosines. Okay. As we look at this and using law of cosines, since we're trying to find the measure of angle L, we want to make sure that we set it up so that its corresponding side is by itself. So as I look at it, that's 10. Okay, so I'm going to set up my equation as 10 squared equals 8 squared plus 12 squared minus 2 times 8 times 12 cosine. I don't know what it is. I'll just call it L. Okay. Because I'm trying to find this angle. Simplifying all my stuff, this gives me 100. Again, I strongly encourage you to separate this so you don't make some of the common mistakes. 64 plus 144 gives us 208. 16 times 12 is 192 cosine L. Okay, so here's the important part here. Again, we do not want to combine these two because we can't combine 208 and 192. So we're solving for cosine L at this point. So the first thing that we need to do is we will subtract 208 from both sides. And so that gives us negative 108 equals negative 192 cosine L. Okay, I need to get this by itself, so I'm going to divide by negative 192, right? I need to get cosine L by itself really quick. So 108 divided by 192 gives us 0.5625. And so now we're trying to find L. We need to get rid of cosine. We'll do that with inverse cosine. So L will equal the inverse cosine of 0.5625. 0.5625. Inverse cosine of that gives me 55.77. Okay, and it says to the nearest 10th degree, so I want to say 55.8. Okay, final question here. It says find all the missing pieces in this triangle. Give angle measures to the nearest degree and side lengths to the nearest hundredth. So again, it'd be really nice to use law of cosines or right triangle trig if we could, or law of sines or right triangle trig if we could, but we can't at this point. So if we want to find another piece of this puzzle, we're going to have to start with law of cosines. Okay, and I'm going to use law of cosines to find my other side. Okay, and so I'm going to call this C. Okay, so C squared equals A squared, 16 squared plus B squared, 5 squared minus 2 times 16 times 5 cosine 61. Okay, plugging all that information into our law of cosines equation formula. So we got 16 squared plus 25 squared. That gives us 281 minus 32, 160 cosine 61. Okay, and so doing that, 61 cosine times 160. I don't know if I did that. I'm pretty sure I did. Okay, so that gives me 77. So 281 minus 77.569539. All that. So that gives me 203.43. So I find that c squared is 203.43. Okay, in order to find c, I need to take the square root of both of these. So square root gives me 14.26. Okay, so the first piece of information or new piece of information is 14.26. Found that that's it. There's hundreds. Okay, so we have that. AB is 14.26. Call it AB or lowercase c, either way. Okay, to find missing piece number 2, I don't need to use law of cosines again. Now that I have a side and its matching angle or corresponding angle, I can use law of sines. And so that's what I'm going to do. I have 14.26 over sine 61. Should help me to find angle A. So I'm going to say 16 over sine A. Cross multiply. Okay, and that gives me 14.26 sine A equals 16 sine 21. 61, sorry. And so now to get A by itself, I'm going to divide both sides by 14.26. So I have sine A equals 16 sine 61 over 14.26. Okay, and to get A all the way by itself, I'm going to have to use inverse sine. Is it 16? A little slow here. All right, 16. All right. So in my calculator, I'll do that stuff. Move this over so I can make sure I'm typing my numbers in right. 61 sine, okay, times 16. Okay, great. Divided by 14.26 equals, okay, so 0.983. And then I'm going to do second. So I can do my inverse sine, and that gives me 78.9. Okay, so we find out that A is 78.9 degrees. Okay, but it says to the nearest degree, so we'll get angle A to be 79 degrees. And since we know that this is 79, and we know that it's a triangle, it has to add up to 180, I can do 61 plus 79. And that gives me 140, so that must mean that angle B is 40. All right, so there we go. Using law of cosines, we should now be able to use right triangle trig, law of sines, and law of cosines to solve our missing information in any triangle. See ya.